Hey everybody, Zachariah J here, IVC Precalculus, Exam 4 Review. Some parts from Chapter 5, Chapter 10, and Chapter 11 will be on this test. This is part 1 of 2 videos. So far in lecture, we've only gone over content that would cover the first 12 problems of the review. So I'm going to go over those now. I just want to remind everyone that I am a student, just like most of the people watching this video. I am not an instructor. I may or may not make mistakes in the video, so do not use this video in place of doing your own homework and trying to do these problems on your own. If you get stuck on a problem, I recommend that you come to the video and look at it. If you still feel that you're not getting the right answer, you don't quite understand, of course, reach out to your teacher. They have office hours. Our instructor for our class is very open to people coming to his office hours and getting help. So, without further ado, let's get on to problem number 1. And question 1 reads, the half-life of radium is 1,690 years. If 150 grams is present now, how long to the nearest year till only 100 grams are present? So this is going to be an uninhibited reactive decay formula model, which is A, the function is A time equals A sub naught E k t. So first off, we need to find out what K is so we can actually fill in the rest of this formula. So it's the half-life, so it's 1/2 A sub naught equals A sub naught EKT. Now, if we divide by A sub naught, that basically clears the A sub naught off of both sides. So we have 1/2 is equal to EKT. Well, we know what K is already. Oops. Hang on a second. We know what K is already, which is 1690 years. So we can do 1/2 equals E. We can substitute the 1690 in here for K, and that's T. So next we have to get rid of this E somehow, and we can do that with the line function. So we have line 1/2, or ln 1/2, is equal to 1690 T. Actually, yeah, ln 1/2 over 1690 equals T. And then if we plug all this into a calculator, we need a calculator to do this, obviously. So write down calculator for calculator work. You plug in ln of 1/2 over 1690, and you get a 0.004100146. And this is a decay, so this will be negative when we plug it into our formula over here. So we want to know when we will get to 100 grams remaining. So we plug in 100. Go back to blue here. 100 equals 150 because that's what we started with. And then that's our A sub naught. Then we have E, and then we're going to do KT. We found out what T. Oh, why did I do all this? Kind of messed up here. We were looking for K. These should all be Ks. My bad. That should be a K, and that should be a K. So put these back in green here. K, 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 and K. So that's our K value, not our T value. It's my mistake. So we plug this in for our K, which was 0.000410146, and T. All right. Now we are going to divide by 150. So 100 divided by 150, that gets us down, reduces down to 2/3 actually. And So 2/3 of E to the 0.000410146 t. Again, we're going to use the ln function to get rid of that E. So ln of 2/3 over, excuse me, over 0.00410146. But these should be negatives because this is decay. This, this video is starting off great and making all kinds of mistakes. So negative 0.0004100146. And that is going to equal our time. So again, can't do this kind of on paper. I mean, I'm sure there is some weird way to do it, but I don't know what it is. So I will resort to the calculator. Dun, 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 dun. I'll plug in ln 2/3 divided by this big long number, and you come out with time is equal to 989. That, of course, is years. And that is the answer for number 1. We'll move on to number 2, and this one involves Newton's law of cooling. And we are given the temperature in degrees Fahrenheit of a dead body has been cooling in a room at 70 degrees is measured at 88 degrees. 1 hour later, the body temperature is 87.5 degrees. How long to the nearest hour before the measurement was the time of death, assuming the body temperature decrease at the time of death was 98.6? Assume the cooling follows Newton's law of cooling, which I already said. So Newton's law of cooling is an equation that looks something like this. Temperature plus U sub naught minus the temperature, and E, and then KT. So just as a reminder, what do all of these values in here mean? So the big T, it means the constant temperature, which in our case is 70. And the U is our initial temperature, which in our case is 88. T, of course, is equal to time. And K is going to be equal to the negative constant. I'm going to try and make sure that I remember it's going to be negative this time, unlike the last problem. So what are we going to do here? Well, again, we need to figure out what K is. So we know the time, it gave it to us already, it was a 1. So let's start plugging these into our formula here. So we have 70 degrees plus our U sub naught, which was our initial temperature of 88 degrees. And that we're going to subtract our constant temperature, which again was 70. So minus 70. Hang on a second. A little technical difficulty here. There we go. And then, of course, E, and then K times 1, because it was 1 hour. But really, we can just say K, right? Because you usually don't put the 1 here. But it was K times the time of 1 hour. Now, all of this is equal to our 87.5, which was the body temperature after 1 hour, right? So we can factor this all down or boil this all down to find out what K is. So we have 70 plus 18E, because 88 minus 70 is 18. K, 1, but just K. And that, of course, is equal to 87.5. Now we can subtract 70 from both sides, and we are going to get 17.5 is equal to 18e to the k. Now, of course, we would divide 17.5 by 18, and that would equal e to the k. And I bet you've guessed by now, to get rid of that e, we're going to use an ln function. So ln of 17.5 over 18 is going to be equal to k. And as before, we will use a calculator to figure this out. And the calculator says this is going to be k is equal to negative 0.028170877. 0877. Yep. All right. So that's our k value. Remember, it's decaying, so that's why we got to put the negative in front of it. It's getting cooler, going down. So where do we go from here? Well, now that we know what K is, and we know what our body temperature at the time of death was, which was 98.6, now we set the whole function to equal 98.6. So 98.6 is equal to 70 plus 18e over, or to the this whole long thing, negative 0.018170.877t, because this time we are looking for t. So we subtract the 70, we get 28.6 is equal to 18. And I skipped this step of 88, or 88 minus 70, because we knew it was going to equal that. So that's where I got the 18e, just in case you were wondering. So, and then 28.6 divided by 18, that's going to equal e to the this long number, blah, blah, blah. And then we will do the ln function again of 28.6 over 18. And all of that divided by, oops, I forgot to put my t's here. This has to be equal to something. All of that is going to be divided by a negative 0.028170877. And that's going to be equal to our time. You plug all this into the old calculator, and you will get time is equal to negative 16.437. So the problem asks us to the nearest hour, so this is going to be 16. It rounds to 16. Technically, it rounds to negative 16, but we just want to know how long ago it was. So we're going to express this in a positive number. So the person died about 16 hours before the initial reading, or the starting body temperature of 88 degrees. So 16 hours earlier. How unfortunate. Pretty exciting though, because now we are all qualified to be working for the CSI. Is it crime scene investigation? Yeah, CSI. So there you go. I guess that's what they do all day, is just do this calculation. Find out who was around about the time of the death. All right, so for number 3 and number 4, basically we need to match the equation to the graph. So this is pretty easy. What we're looking at is, what is the vertex of this equation, really? So we have 1, negative 2. That's the vertex that I get out of the equation. This doesn't have it. This doesn't have it. This one, number C, looks like 0, negative 1, so that's not right. That only leaves us B left. And sure enough, if we look, we have 1, negative 2 is the vertex. So we'll just leave it a crappy square instead of the weird rhombus looking thing. All right, so for number 4, we do the same thing. We have a notice also we have this negative sign. That means it's opening down. So we can automatically eliminate C. So our parabola opens down. So our vertex is 1, -1. Now we just need to find one that has one of the that's 1, -1, and A isn't it because that's a positive. This one looks like 0, -1, so that again leaves us only B. And sure enough, if you look, it's 1, -1 is the vertex right there, that little dot. So pretty easy problems on that one. Hope those are on the test. Those are free points almost. All right, here we go with number 5. And number 5, we are find the vertex focus, the directrix of the parabola, and then graph it, of course. So we're going to complete the square on this one. So we have x squared minus 12. That should be 12x, but I forgot the x. Anyway, plus some number, which is going to be 36. We put the 36 on both sides. And we are going to get on this side x minus 6 squared, or the quantity x minus 6. Come on, pen. Wait, that's going to be 40. Okay, so that'll make it easy. 8 quantity, that's 5. That's that side. And then on this side, we'll have x minus 6 squared. So this is what this all factors into, just so we can get the vertex of 6, comma 5. All right, so next we need to find our focus, which is the 8, which is 4a. 8 equals 4a. So really we end up with 8 divided by 4, which equals 2, which means we'll plot our 6, 5 here. Do my side work here for you guys. That's 8 divided by 4, and that equals 2. Now we know this is a parabola opening up, so this 2 affects our y value. So if we want to find our focus, it's going to be 2 units up from our vertex. So really we are going to have 6, comma 7 for our focus. And that is that point right there. So we can write down, go over 4, go over 4 this way. That's our 4a distance. So there's our parabola. And then, of course, our directrix is going to be 2 down, so it's going to be y equals 3. That's where that is. So we can put y equals 3, and then, of course, our focus, which was 6, comma 7. Kind of got all crazy on that one. It's crazy town on math today. All right, so for number 6, exactly the same type of problem, although notice the y's are on the left and the x's are on the right. So when we set this up, we have to make sure that we pull the vertex in correctly. So y squared plus 6y plus some number equals 4x plus 15 plus some number. We fill this in, we get 9 on these two sides. This is going to be y plus 3 squared equals 4 times the quantity x, and that's 24, and divided by 4, 6. So this is going to be 6. There we go. So our vertex is -6. Remember, it's on the right-hand side of the equation this time because it's with the x. So don't get this backwards where you do -3, -6. Make sure you figure out the x components coming from the x and the y's from the y. So we'll plot that number. And there's that dude. Now we are going to get into some craziness. We got our A is equal to 1. So our focus is just 1 over, and our directrix is 1 over as well. So x equals -7, and our focus is -5, comma -3. And then if we wanted to draw the rest of this, we obviously do 4 times a, which would be 2 each direction from the focus. And there you go. That's number 6. Number 7, we have, again, a y on the left and x on the right, so we need to make sure we pay attention to that. This means our parabola is laying over on its side, but it opens to the left because we have a -6. Remember that. We're looking for our vertex focus and directrix here. And this one's pretty easy. We don't have to do any weird factoring or anything, so we get 1, 1 for our vertex. We'll put our vertex here, 1, 1. Now we need to figure out what our focus is, and that's 6 equals 4a, so we're going to 4 over, and now we're going to get 3 halves is equal to a. Well, we are at 1, so 1 minus 3 halves, I'm going to get 2 over 2 is equal to 1 minus the 3 halves, and that equals -1/2. And then we do, of course, the other direction, and so we get 2 over 2 plus 3 halves is equal to 2 halves, or 5 over 2. So our directrix is going to be x equals 5 halves, or the 2 halves, which is what I got down below. If you want to keep it all in fractions, I think we're supposed to keep it all in fractions, but anyway. So I can put my directrix right here, and I'm going to put my focus over here. It's going to be -1/2, 1 right here. That's my focus. And of course, if we are -1/2, 1, so our focus is 1.5, so that's 3 up. So that puts me at 4, and 3 down, which puts me at -3, right on the half line, of course. And then we can finish drawing this parabola. And there you have it. So number 7. Those 3 are pretty much all the same problem, just a little bit different numbers. Number 8. Oh my gosh, number 8. A bridge is built in the shape of a parabolic arch. The bridge arch has a span of 198 feet and a minimum height of 30. Find the height of the arch at 20 feet from the center. So here we go. We got 198 feet across. We'll put the little bridge up here at the top. Hand railing. I don't know if it's card bridge or a walking bridge, but we can put a little person up here. It doesn't really matter, but that's a bridge. And of course, this would be somehow connected to this supporting arch. If you want to become a civil engineer, you'll understand all of this. And there's probably some other supports that go from that arch up to the bridge to support it. So this is basically what we're trying to solve here. We have this arch, but we want to know how high the arch is going to be 20 feet from the center. And the bridge is 30 feet tall overall, so we'll mark that. This section, or half of this, is going to be 99 feet, which is half of 198 divided by 2. That's 99 feet. Pretty simple so far. We want to know about 20 feet, drawing not to scale. 20 feet, we want to know what this height is. We know it's 30 feet at the middle, but we don't know what it is 20 feet from the middle. So we're going to exploit our few things here. We know the center and the bottom, we'll just set that to be 0, 0, which means this would be 0, 30, because it's 30 up. And over here would be like -99, 0. The other end obviously would be 99, 0. And we're looking for this, which is 20 something. We don't know what this y component of this is going to be. So we want to know our vertex is 0, 30, and it opens down, right? So that means we're going to have a function or a equation with a negative a value. So we were to write a formula for this, we'd have x squared equals negative 4a because of this opening down business y, right? This opens down, so that's why this negative's here. Very important for this to be an arrow too. There we go. All right, so let's start plugging in what we want to find, or what we know, so we can find what we want to find. So we know that the half of the bridge that we're trying to talk about here is only 99 feet, right? So we have 99 squared is equal to negative 4a, and our y is 0 minus 30. And that comes from our y value being 0, and we are 30 feet down, negative 30, right? Oh, I forgot to label this guy. Not that we really need that one, but anyway, we're dealing with this side of the equation, so I might as well. So 99 squared, calculator time, 9801. That 0 there really didn't come from this 0. It came from the one on the vertical axis. But anyway, so 9801 equals negative 4a minus 30. And then we will multiply negative 4 times negative 30, and that's 120. 9801 divided by 120 comes out to be 81.675. So that's what our A value is. Now we need to find what is our Y value when X is 20. We know what happens when X is 99. It's 81.675. But we don't know what it is when X is 20. So we'll plug all this stuff back in. We'll make our X value 20. So it's going to be 20 squared is equal to negative 4 times our 81.675, because now we know what the A value is. And that is going to be equal to y minus 30, because we're going to know the altitude from the bottom here. So negative 4 times the 81, all of that shenanigans. And 20 squared, of course, is 400. So, and then the 81.675 times negative 4 is going to be negative 326.7. Don't worry, I did that with a calculator. And this is going to still be y minus 30. 400 divided by 326.7 is equal to y minus 30. And then 400 divided by negative 326.7, that whole fraction plus 30 is equal to y. Plug all this into a calculator, and we are going to get y equals 28.78 feet. So that's how high the arch is from the ground at 20 feet. Number 9. Oh my gosh. We have to reorder this whole thing. So we'll do 2x squared minus 24x plus 5y. And what is the other y? Plus 70y. And we'll set that equal to negative 307. Just move that 307, get that out of the way right now. Now we're going to have to complete the square twice. Once for the x and once for the y. So we're going to end up with an ellipse. So we'll get 2 times x squared minus 12x plus some number plus 5y squared plus 14y plus some number, yeah. And that's all equal to negative 307 plus some number, those two blanks from the other side. So complete this square. We're going to get 36 goes in here. Half of 12 is 6. 6 squared is 36. 36 times 2 is 72. Remember, we have to multiply this number times what's out front there. So we get 72. 14 divided by 2 is 7. Squared, 49. 5 times 49 is 245. Using a calculator on that guy for sure. And there you go. If we combine all this on this side, we're going to get 10, which works out nicely for us. So now we can factor all this down to 2x minus 6 squared plus 5y plus 7 squared equals 10. Divide by 10, so we get 1 on the outside there. So divide everything by 10. This 2. And you will get a leading coefficient of 1 in front of both of these. So we will get x minus 6 squared over 5 plus y plus 7 squared over dos, or 2. And that will be equal to 1. That is our equation for this. So now we can see our center is 6, negative 7. Now we need to find our foci and our vertices. Well, we know c squared equals a squared minus b squared. We have our a squared and our b squared, which is 5 and 2, right? So 5 is our a squared and 2 is our b squared. So we're going to have an oval that is horizontal. We should also know that just by looking at it. So 5 minus 2 equals c squared. So that means 3 equals c squared. So plus or minus the square root of 3 equals to c. Now this affects the x-axis because we have a horizontal oval. Remember, I just said that a minute ago. Since we have this 5 here and it's with the x, that means our oval is going to go this direction. So when we're looking at our foci using our c, what we just found c to be, we are basically going to take 6, and then it's, yeah, I'll just write this here. This affects the x in this case because of that horizontal oval. So we'll just do 6 plus or minus 3, or sorry, plus or minus the square root of 3, comma, negative 7. That is our focus, or foci, the two of them. Focuses. I think it's foci. Anyway, now we need to find our vertices, and we have a squared is equal to 5, so a is equal to plus or minus the square root of 5. And again, this is going to affect our x-axis, or our x value, really. So we can write our vertices as 6 plus or minus square root of 5, and then negative 7. That'll produce 2 points. Now we can draw our 6, negative 7. It's right there. And let's plot this guy. It's going to be 6, 8, a little more than 8. Ballparking. Because, again, oh, and it'll be a little less than 4 on this side. So there's our vertices. We don't need to plot our foci, but we need to know what that A is so we can plot these two guys. It's going to be somewhere right around there. So now we have an oval. Remember, our a value was plus or minus square root of 3, so we would do plus or minus 4 times the square root of 3 to get that full distance. So half of that up and down. All right, so number 10, they actually, whoa, here we go. Number 10, they actually just give us the formula all set out for us. We don't have to do any crazy moving things around and all that kind of stuff. So these are the 4 things we need to find here so we can draw this or graph this. First off, we got our center is going to be -2, -1. So we get that from the y and x values on the top. And we have a oval that's going to go vertically because the larger number is with the y. So since that's the case, most of our calculations that we're going to figure out, like 16 minus 4 equals a, this is going to affect the y in the end. Oops, c squared. Let's mess that up. All right, so 16 minus 4 is 12. So we got 12 is equal to c squared. Oh my gosh. There we go. C squared. There we go. And so that means the square root of 12, which is 2 square root of 3, is equal to c. And that, of course, is plus or minus. Plus or minus. And that's c. And again, like I said before, because this is a vertical circle, we are going to affect the y-axis. So when we look at our center, I'll write that down here, it affects the y. So when we look at our center point, we are going to add or subtract 2 square root of 3 to the y because it's a vertical circle. Or vertical oval. So that's what's going to happen with our foci. We have -2, comma, -1 plus or minus 2 square root of 3. It's important to know if it's a vertical or horizontal oval so you know which one, either the x value or the y value is what you're going to use this c, what we found c to be. All right, so we need to find the square root of 16. This is equal to 4. That is going to affect the y-axis as well. Affecting they. No, that's affecting the y. So this is how I'm looking at my vertices. That's 2, comma 3, and -2, comma -5. So -2, comma 3, and -2, comma 5. So I just moved the 4. The square root of my a squared is 4. So it's 4 up on my y and 4 down. So 4 up from this -1. Now my co-vertices is the square root of my b value. So plus or minus the square root of 4 is my b. So plus or minus 2 is equal to b. Now this guy is going to give me, nope, not that. Now I'm affecting the x value because I'm trying to find the co-vertices, which are along the narrower side. So it's going to be 0, comma, -1, and then -4, comma 1. Oops, -1. So let's plot this guy first. It's going to be -2, 1, -1, which is right there. And let's plot these guys because they're whole numbers. It's easier. Yeah, get this a comma. And we will do 0, -1, and -4. Oops, there's this negative in front of this. I know I said it. I don't know why I didn't write it. But Anyway, -4, -1. Now that's the narrow part of our oval. Let's do the long part of our oval. We'll do these because they're also whole numbers, easier to plot. It's -2, 3, and -2, -5. That's really the whole thing. We don't need to plot the foci, but there you go. It's a diamond. Yay! No, make an oval. Let's see if we can make a nice oval. Nope. Computer says no. It says diamond. We'll leave it like this. All right. Move on to number 11. Number 11. What does that say? Something about a racetrack here. Is in the shape of an ellipse, 80 feet long, 60 feet wide. What is the width at 32 feet from the center? So I've got a racetrack drawn here with a center and a vertical. So it's 80 feet all the way across. This whole thing is 80 feet. And the vertical is 65. So, and half of 80, of course, is 40. So from this to the center is 40. The vertical, the whole thing is 60. And of course, half of that is 30. All right. Like all these feet. What to do next here? Well, we want to know what this width is, the whole width all the way across. And that's 32 feet from there. So we'll write down our formula for an ellipse here, which is, and we'll put the center at 0, 0, so we don't have to deal with anything fancy. So we have x squared over a squared plus y squared over b squared is equal to 1. So x squared over 40 squared plus y squared over 30 squared is equal to 1. And we can further push this down. 40 squared is 1600. 30 squared is equal to 900. What craziness is this? All right, x squared over 1600, just like I said, and y squared over 900, and that equals 1. And so now we want to know what the height is when we are 32 feet from the center. So we'll just put 32 in for x, 32 squared over 1600. And we'll solve for y. Y squared equals, or over 900, and this all equals 1. So we'll just solve for y. We are going to definitely bust out the old calculator here. Calculator time. 32 squared divided by 16. I can't spell calculator and type on a calculator at the same time. This is all going to equal 0.064 plus y squared over 900 equals 1. I don't know what that says. Y squiggle. It's supposed to be y squared. Y squared over 900 is equal to 1 minus the, no, not 0.0, 0.64. Now I'm going to multiply by 900 both sides. That'll get me y squared equals 900 times the quantity 1 minus 0.64. And so then we square root that. So we get the square root of all of this shenanigans, which is going to also be another job for our hero and savior, the calculator. And calculator. And that is going to give us y equals 18. Now, this is only half of the line, so we have to multiply. We want to know the whole height, distance across, the entire distance. So it's 18 times 2, which is equal to 36 feet. So that is our final answer for this guy. All right, on to number 12, which is the orbit of a planet around the sun is an ellipse with the sun at one focus. And the aphelion of the planet is the greatest distance from the sun. The perihelion is the shortest distance. And its mean distance is the length of the semi-major axis of the elliptical orbit. If the planet has a perihelion of 335.7 million miles and the mean distance of 338 million miles, write an equation of the orbit of the planet around the sun. So this ellipse almost looks like a circle, which it should. And the shortest distance from the focus is 335.7, and the focus being the sun. And the difference between the half of the major axis, which is 338 million miles, is 2.3. So that's the distance the focus is from the center. There you go. And it should make sense. As the focus gets closer and closer to the center, it becomes more and more of a circle. So 338 is our A, and 2.3 is our C. So we have x squared over 338 squared plus y squared equals b squared equals 1. Over b squared equals 1, sorry. And we're going to look for b squared. We know what c squared and a squared are, so this is our formula to find all of that. So we can just plug and play. We can do 2.3 as our c. So we'll put in 2.3 squared is equal to our a value, which is 338 squared, minus b squared. So you can see where I'm getting all those numbers from inside here, where I've already labeled them. Now, we'll shuffle this around. I don't like having to deal with the negatives, so I'm going to shuffle b over. So I know this ends up meaning I have one extra step, but it just makes it so I know that I get it correct. So 2.3 squared plus b squared equals 338 squared. Now I have b squared is equal to 338 squared minus 2.3 squared. Yep, and you guessed it, I'm going to use a calculator. And calculator says b squared is equal to 114,238.71. And that's in millions of miles. So our b is actually the square root of all of this, which turns out to be 337.99 million miles. But that's not our answer. The question asks for the equation, not just the b value. So we are going to write the equation, which is x squared over 338 squared plus y squared over 337.99. And to be more exact, this was actually 2, 2 as well. So we'll put our 2, 2 on the end because they didn't tell us how close. And that, of course, the b needs to be squared as well. So 2, 2 to the 2. 337.9922 to the second. So there's the first half. I'll do the rest of the questions later. Probably will try and do them Tuesday. If not, I should have the video up by Thursday of next week. So that'll be my target, my goal. And hopefully this video has been of some help to you guys. And I'll see you in class on Monday. And if you're in the early class, you can, of course, hit up comments in the down below. Also, please subscribe, like, so you know when the videos are coming out. Our instructor, usually I give him the videos, but he doesn't email you guys that they're ready until after he's done lecturing. The main reason for that is he doesn't want people to just not show up for class, which, again, I should not be a substitute for teaching the class at all because, as all of you know, I do make minor mistakes and you don't want to repeat those minor mistakes. So make sure you come to class, get all the information I'm getting so you can have a better understanding of how to do the problems correctly. Anyway, hope you see you all soon, and I'll talk to you later.